Hello, it's Keith here, and this is lesson 2 of the SuckShoot series of my PDP11 assembly programming tutorials. SuckShoot is the little game that you can see here, if I just move it a little bit. It's a very simple game, a bit like Duck Hunt basically. We have a bat, the bat flies closer towards the player, and we have to shoot the bat before it gets to the front of the screen, which it did there. If it gets to the front of the screen, we lose a life, but if we kill the bat will get faster, and the game just goes on forever until we get incredibly bored and give up. Now, of course, this isn't really a very impressive game, but it's a little example of all of the things you will need to write a game on this system. We've got a graphics routine, a joystick, a keyboard reading routine in this case, a sound driver, and we've got some movement and things, animation and things. So we're going to look at the rest of the code today, and you can see we've just got a high score, and that's relevant because we're going to look at the high score code. You can see there's a new high score there, so that's part of what we're going to be seeing today. So we looked at the sprites before, we discussed how the sprite routines worked, and a lot of the modules are based on stuff in the multi-platform series and the platform-specific series of my PDP11 tutorials. So we're not going to go over that code because it's covered in those episodes, but we're going to go over the general code today. So let's go over to the source and let's take a look. Okay. Now, the first thing that I don't think we've mentioned yet is how we're randomizing the enemies. So when the enemy restarts, we are specifying a new random X and Y position for the enemy. And we're using this ranged random routine here, which is very simple. It just uses the do random routine, and it checks that the value that's returned is between R1 and R2. And until it is, it keeps pulling out new random numbers. And because my random number generator, given enough time, will produce every possible value from 0 to 255, we will definitely at some point get a valid value. So that's what we're doing there. Now, we are using that to get a valid X position in bytes and a valid Y position in lines here. So we're calculating our new position for our bat based on that, and we're storing those in ENX and ENY, which are two variables in memory. Now, we're also at the same time setting the scale to the minimum, and the minimum scale for the small bat is 16. We're storing that in enemy scale here. And this is used when the game starts, but also whenever we need to reinitialize the bat, either because the bat has bitten us or because we've just killed the bat and there's a new bat. So that's what that's used for as well. So at the start of our main program loop here, this is the main loop of the game. So this just cycles until the game has ended in one way or another. And the first thing we're doing is we're checking this stout variable here. This is sound timeout. Now, I use my simple chibi sound driver, which makes beeps based on a single byte value. But we can silence that beep. It will continue until we send a 0 byte to the chibi sound driver. So we might want that sound to play for a little while. We don't want to stop it immediately. And so sound timeout is just a counter that goes down until it reaches 0, at which point we are sending it to the chibi sound byte C sound A, which will effectively silence the sound. So that's just the simple sound driver here. Nothing very clever, but it's just enough for an odd beep and bloop. Now, what we're doing first here at the start of the main loop is we are XORing the enemy sprite number. The sprites will toggle between 0 and 1. Now, there's 3 different sizes of sprite, but there's 2 frames of animation for each, and so we're just toggling between them for that. We're then going to show the player, show P, and show the enemy, show E, and then we have a delay. We're just waiting a while, and of course if you make that smaller, the game will get faster. But what we're then going to do is we're going to run those routines again, and that's because these are XOR routines. So the first time we run them, we're showing the sprites, and the second time we're removing the sprites from the screen, and that's because we're going to potentially reposition those sprites and change them. What we're then doing is we're reading in the key test variable. Now, this is set by the interrupt handler, so this will have any key presses. We are simulating a joystick. We read in various keys, and we're simulating a joystick. And so we're using the bit command, and we're testing each of the directions. And if the direction is viable, if the player's not already at the top and we've gone up, or if the player's not already at the bottom, we go down, we are changing R2 and R1 accordingly. Now, we're moving in lines here, so we're moving 8 lines at a time. That's 10 in octal, of course. And we are moving in bytes here, so we're incrementing and decrementing the bytes here. So that's how we're dealing with the player's movements. Now, when it comes to the bat, first what we're going to do is we're going to check if the player has pressed fire. If the player's pressed fire, we're going to make a fire sound. So we're storing a new value in the chibi sound byte here. That's going to make a kind of a noise sound there. We're setting a sound timeout. And then what we're doing here is we are going to use the range test routine to check if the player is in range to shoot the bat. So what we're doing here is we're getting the player's position from R1 and R2 into R0 and R1, which is the variables that needs to be in for that range test to work. We're of course backing up the true values onto the stack. We're then getting the enemy position here and we're getting the range, the width and the height of the valid range here, and then we're using the range test, and we are going to skip over the next section if the player has missed the bat. Now, in theory, actually, you can just keep holding down the fire. There's no limit to the amount you can fire in this game. It might be nice to have something like in Duck Hunt, where you only have 2 bullets or something to stop someone doing that. But as I say, it's only a simple little test game. Now, if the player has hit the bat, then what we're going to do first is we're going to increase end speed, which is enemy speed. I had to keep all of these down to about 6 characters, so they were quite short. But that's the speed of the enemy. So every time the player kills the bat, the next bat will be a little bit harder. So give them some more challenge. We're then changing the chibi sound bleep because the last one was for firing and this one is for hitting the bat. We are then going to reposition the enemy, but select a new position, and of course resize the enemy. And then we're using BCD add, and we're going to add 5 points, that's BCD 5, to the score. It's a 4-byte score, so that's why we've got 4 in R2. And that is covered in the multi-platform series, that by BCD routine. We've got update score here as well, which just shows the text onto the screen. Nothing else very clever there. We're then restoring the X and Y position of the player. What we're doing next is we're going to now consider the enemy getting bigger. So the first thing we're doing is we are adding enemy speed to enemy speed B. Enemy speed B is the temporary speed, if you will. This is used as a counter for when we actually need to increase the Z position, or the size of the bat, if you will. So when enemy speed B rolls over to 0, we are then going to effectively change the scale. So we're adding 2 to the scale here. Enemy scale is used to select one of the 3 sprites, and it's effectively the Z position, if you will, so as the bat gets closer to the screen. So if the bat has got to position 64 in decimal, that is the front of the screen, so the bat has now hit the player. In that case, we're randomizing the enemy again. We're giving the bat a new position. We're making what we could call the ouch sound, because the bat has bitten the player. And we are then decreasing the number of lives, and if the lives have reached 0, we're going to go to the game over routine. Now the game over routine is just here. So this is going to show the game over screen and update the score if required. So first what we're doing here is we're clearing the chibi sound byte, and that's to silence any existing sound because we don't want an annoying beep throughout this routine. Clearing the screen, nothing too exciting there. We're showing the game over text at this text position here. We're using this lprintf, which locates and prints a string. We're then loading the no high score message into R5, but we may not want to show that because if the player's got a high score, we've got a different message for them. We're then loading the current score and the high score into R0 and R1 and the number of bytes to compare in R2, and we're using BCD compare, which compares 2 binary coded decimal strings. If the player does not have a high score, we're then skipping over to no high score. If the player has got a high score, though, we need to do 2 things. We need to update the high score to the current score. We're doing that with a sequence of 2 16-bit moves, effectively moving 4 bytes there. So that is copying the current score to the high score. And we're changing the text string to text high score here. And we're then showing whatever string is currently in R5 to the screen here. And that will either be the nice message of new high score or the not so nice message of you suck. So there we go. So we've got some vague insulting of our player to try and encourage them to do a bit better next time. Anyway, whatever the message that was shown, the next result is basically the same. All we do once we've shown our string to the screen is we repeatedly read in from the keyboard byte here, and we wait for the fire button to be pressed. Now, of course, on this system, it's an interrupt handler setting that byte, so there's no call out to a read joystick routine, which there usually would be on this kind of game. But in this case, we just keep reading that byte until we get the fire button. Once the fire button's pressed, we just jump back to the show title, which it reinitializes for a new game. So here it is, and we're just starting up everything again. So that's really all there is to it. Now, as I always say, all of the source code for today's example is available on my website, so you're welcome to go ahead and get it. Now, also, you're welcome to use any part of it you want in any of your own projects, and as I always say, if you somehow manage to make something commercial, go ahead, you're welcome to do so. I don't care, that's what it's there for. I hope you've enjoyed what you've seen today. If you have, please like and subscribe. If you like the videos, YouTube recommends them to more people, and if you subscribe, well, I know that it's worth me keep covering these weird systems like the UKNC, which is a bit of a strange one. Anyway, hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.